Good morning all.
So today we are going to discuss a numerical which is based on the acceleration analysis. Here we have a link OR on which a slider is moving with some velocity. So in this case we have several input data. What are those? So the input data are, this is V, the velocity of the slider, this is A, the linear acceleration of the slider. The distance between the fixed point and the slider is given to us as 1.5 meters, and this link QR is rotating with some omega 6 radian per second in the anti-clockwise direction and some angular acceleration alpha in the clockwise direction given to us as 20 meter per second. So the given data is the distance between OP or OQ is 1.5 meters. So this P point represents the point on the slider, and to that corresponding point P on the slider we have a point Q on the link QR as well. So both are equal. Next we have the linear acceleration 10 meter per second, the velocity of slider 4 meter per second, omega as 6 radian per second, and alpha as 20 meter per second. So let us solve it by first calculating the velocity of point Q on link with respect to the fixed point O, which should be given as the omega into the distance of the point Q from the fixed end, which is OQ. Omega is given to us as the 6 radian per second and OQ is 1.5. So this will come out to be as 9 meter per second. So this is the velocity of the point Q which is on link OR. Okay, so this is VQO. Now to calculate the acceleration associated with this system. So first one, since we have angular acceleration alpha value with it and a slider is sliding on a rotating slider, so we will be having a radial acceleration here, a tangential acceleration, and we also have a slider, so there will be some Coriolis acceleration as well, and a linear acceleration of the slider is already given to us as 10 meter per second square. Now to calculate different accelerations associated with this system. So radial acceleration is given as of this point P, it should be toward the fixed point which is O. So it is given to us as velocity of P with respect to O, or we can write it to be as Q with respect to O square divided by OP. So this is given to us as 9, so it will be 81 divided by 1.5. Okay, so this will represent the radial acceleration of point P with respect to the fixed point Q. So it is given to us as 81 divided by 15, which will come out to be 54 meter per second square. Now the tangential acceleration, which is given as alpha into O Q or O R. Okay, so this is equal to alpha is given to us as 20 and this is 1.5. Okay, so this will come out to be as 30 meter per second square. The Coriolis acceleration is represented as 2 into omega into v, so it will be 2 into omega is 6, v is 4, so it will be 48 meter per second square. These are the magnitudes. Now what will be the directions? So direction of radial acceleration will be from point Q to O. So this will be the direction as represented here. So this is the radial acceleration of point Q toward R. What would be the direction of the tangential acceleration? So tangential acceleration is perpendicular to the length and in the direction of the alpha. So alpha is clockwise, so this will represent the direction of the tangential acceleration at of QR. Okay, next we have the linear acceleration, which is given to us as 10. So this is linear acceleration, and last is the Coriolis acceleration. Since this slider is moving in this direction, in the forward direction, and the omega is in anti-clockwise direction, so we will turn the velocity vector of this slider by anti-clockwise 90 degree, so that will result in this direction. So this will be the direction of the Coriolis acceleration. So tangential is in this direction, Coriolis is in this direction, and linear is in this direction. Now to draw the acceleration diagram for these given accelerations, we can draw it like this, that from a point we have given the linear acceleration as 10 meter per second. The radial acceleration is in this direction, which is the 54 meter per second square. For the vertical, we have the Coriolis acceleration as 48 meter per second square, and we have a tangential acceleration as 30 in the downward direction. We can draw an equivalent diagram of this by 54 minus 10, that will give us 44 meter per second in this direction, and 48 minus 30, it means that 18 meter per second in this direction. 18 meter per second in this direction. In order to calculate the resultant acceleration, we can use the Telogram Law and can easily find out the resultant, which can be given as under root of, so the resultant acceleration will be under root of 44 square plus 18 square. So we can calculate this data by using any calculator. So 44 square will be equal to 1936, and 18 square will be 324. So 1986 plus 324 will make it to be as 23 under root of 2310. We can find out the under root of this 2310. We can easily find out the under root as 2310, which will come out to be as 48.06 meter per second square. So this is the final acceleration of this system. Okay, so thank you.